In this video, we will learn how to perform the hypothesis test for the difference of population means using t-test. An industrial plant wants to determine which of two types of fuel, electrical or gas, is more cost efficient, measured in cost per unit of energy. Independent random samples were taken of plants using electricity and plants using gas. These samples consisted of 11 plants using electricity, which had a mean cost per unit of $57.5 and standard deviation of $8.33, and 10 plants using gas, which had mean of $48.7 and standard deviation of $8.7. Assume that the populations of costs per unit are normally distributed for each type of fuel, and assume that the variances of these populations are equal. Can we conclude at the 0.05 level of significance that the mean cost per unit for plants using electricity, mu sub 1, is greater than the mean cost per unit for plants using gas, mu sub 2? Carry your intermediate computations to at least 3 decimal places and round your answers to at least 3 decimal places. First of all, I identify what I know. I know that sample size for the first sample of plants is 11, mean is 57.5, and standard deviation is 8.33. For the second set of plants, sample size is 10, mean is 48.7, and standard deviation is 8.7. I want to identify an important piece of information given to us that allows us to use t-test. We must assume, or at least we must know, in this case we are told to assume, that the cost per unit are normally distributed for each type of fuel, which allows me to perform the t-test with such a small sample of 11 or 10. We also are told that we can assume the variances for these populations are equal, which tells me that I'm going to use pooled test. That's the requirement that we must have in order to use the pooled test. All right, let's set up our hypotheses and find out how we're going to do that. The question we're trying to answer is the following. Can we conclude that the mean cost per unit for plants using electricity, mu sub 1, is greater than the mean cost per unit of plants using gas, mu sub 2? In other words, we are trying to answer the following question. Is it true that mu sub 1 is greater than mu sub 2? Or equivalently, is it true that the mu sub 1 minus mu sub 2, the difference between them, is greater than 0? Why? Because if I have a larger quantity minus the smaller quantity, if that's true, this must be true, larger minus smaller, the result of the difference should be bigger than 0, positive. So that is the statement that goes into alternative hypothesis. We would like to find evidence to support this statement. Meanwhile, we assume the opposite is true unless proven otherwise. So null hypothesis says mu sub 1 minus mu sub 2 is less than or equal to 0. Alternative hypothesis H sub 1 says mu sub 1 minus mu sub 2 is greater than 0. State your alpha and go ahead perform the test using 2 sample t-test, fourth option in the list of tests on TI 84. When you enter the information provided to us over here into this test, the test statistic t comes out to be 2.367 and p-value comes out to be 0.014. We are using the p-value method to perform this test, so I'm comparing p-value to alpha. Remember, if p-value is less than or equal to alpha, we are going to reject H sub 0, always. And in this case, it is exactly what happens. 14 thousandths is less than or equal to 500, so we reject the null hypothesis and accept the alternative, of course. So we say there's enough evidence at alpha equals 0.05 significance level that the mean cost per unit for plants using electricity is greater than the mean cost of plants using gas. Using the diagram here, I would like to, again, support this with a visual. We have a T-curve. We have a 5% significance level, so 5% of area is in the right and 95% is on the left side of this critical value. Because I'm using the p-value method, I don't really want to know, or I don't really need to know what this critical value is. What I do know is that the area p-value to the right of this test statistic t happens to be a very small quantity compared to the significance level of alpha, and therefore I am deep in the rejection region and reject the null hypothesis for that reason. Let's take a look at how we use TI-84 to perform this test. We go to Stat Tests, choose option 4, choose sample t-test. We have stats to enter, so I'm going to enter the sample mean of the first set, 57.5, sample standard deviation for the same set, 8.33, sample size was 11, second sample has mean of 48.7, standard deviation for that sample is 8.7, and sample size is 10. I have a right tail test, so choose the greater than, make sure to enter, press enter to highlight that permanently, and make sure pooled is chosen to be yes, and then click calculate to get the numbers. These are the numbers we saw previously. T was 2.367 and P was 0.014. Please notice something very important. Do you see that degrees of freedom on the screen right here shows to be 19? When you are entering your answers in ALEKS, it will ask you for degrees of freedom whenever you work with T curves. So how did we come up with 19? I want to remind you of that. Because we are using a pooled test, we have to pool together the two samples. And degrees of freedom in this case is computed by combining sample 1 and sample 2 and subtracting 2, 1 from each sample. In our case here, degrees of freedom will be 11 from first sample plus 10 from the next one minus 2. 11 plus 10 is 21, minus 2 is 19. That's how we come up with degrees of freedom 19. So make sure to enter that number into your field, into your table on ALEKS when you answer this question. Here is the second example, and this time we have raw data provided to us, so I wanted to demonstrate how to deal with this kind of question. Amy has two ways to travel from her home in Norco to her office in Los Angeles. One is to go via the 10 freeway, and another is to go via 60 freeway. In order to determine which way she should travel on a daily basis, Amy has recorded the travel times for samples of 11 trips via the 10 freeway and 11 trips via the 60 freeway. The following table gives the travel times in minutes for the 22 trips. Assume that the two populations of travel times are normally distributed and the population variances are equal. Can we conclude at the 0.05 level of significance that the mean travel times of the two routes are different? Carry your intermediate computations to at least 3 decimal places and round your answers to at least 3 decimal places. First of all, I would like to highlight a couple of important statements. Assuming that two populations of travel times are normally distributed and that the population variances are equal are very important statements for us. They both allow us to use t-test with a pooled setup. Remember, to use the pool test, I must have population variances equal, and in order to use the t-test at all, I must make sure that the populations are normally distributed because sample sizes are not sufficient to do it otherwise. Another important statement that I would like to highlight is the statement that will help us to determine the hypothesis. We would like to know, can we conclude that the mean travel times of two routes are different? This word different tells me that this will be the not equal to setup or two-tail test. So here we go. We are going to set up our hypotheses, and they are the following. Null hypothesis will say that there is no difference between the two means. Mu sub 1 minus mu 2 is equal to 0, so no difference at all. They're same. And alternative hypothesis will say, oh no, mu sub 1 minus mu sub 2 is not equal to 0, therefore there is a difference between these two means. Alpha we have of 5%, I am applying the two sample t-test, fourth option on our list of tests, and it gives me the following outcomes. T-value, the test statistic is negative 1.013. P-value is 0.323. I also record a few more important numbers that TI-84 provides me with. It tells me that degrees of freedom is 20, and that comes from the fact that we have 11 in one sample and 11 in another sample, so 22 altogether in my pooled sample size. And degrees of freedom for pooled sample size is found, again, I would like to remind, degrees of freedom is equal to n1 plus n2 minus 2, which would be 22 minus 2, or 20. Let's continue. My sample means from both lists is provided by the calculator, and sample standard deviations are also provided by the calculator. But my main focus should be on the p-value. P-value of 0.323 is definitely not less than or equal to 0.05 level of significance. Therefore, I do not have enough evidence to reject the null hypothesis, and I have to stick to it. I have to accept it as still true, still holding to be true. In other words, we don't have enough evidence at alpha equals to 0.05 level of significance to conclude that the mean travel times of the two routes are different. So for Amy, it doesn't matter which way she is traveling, she will run into traffic one way or another. That's what LA is about. Let's take a quick look now at how we do this test using TI-84. I'm going to go to Stat and choose Edit to get to my lists. Please notice I already entered the information into list 3 and list 4, and those are the two lists I need to remember to use within the test. I'm going to use the fourth option, two sample t-test, and I will choose the data feature of this test because my data information is provided to me in raw format. So I enter list 3, list 4. I choose the two-tailed setup for not equal to, pooled, yes, and calculate. This gives me the test statistic of negative 1.013 and p-value of 0.323, degrees of freedom 20, and the rest of the numbers that we saw on the previous slide. So that's how you can use the TI-84 to do the work for you, and all you need to do is interpret this result and state the conclusion.